Hello everyone, let's go ahead and take a look at factorizing. Now, in order to understand factorizing, let's go ahead and first start off with distribution. Here's distribution again. We have A times the quantity B plus C is going to be equal to AB plus AC. Now factorizing, on the other hand, is actually going to take what we had as a result of distribution, and it's actually going to give us back the form that we had before we distributed. So let's go ahead and take a look at what the differences and the similarities are between distribution and factorizing. Now, one of the things that we should notice when we're talking about distribution is that it eliminates the grouping symbol. So when I distribute the A to the quantity B plus C, then I come up with AB plus AC. There's no longer any need for any grouping symbols. Now, on the other hand, when I take a look at factorizing, factorizing actually introduces a grouping symbol. So what I have here is AB plus AC, and notice that the result is actually going to have a grouping symbol there. Now, the other thing that we want to pay particular attention to is the differences between the results. The result of distribution is an expression of terms that are added or subtracted to each other. So notice that what I have here is I have this term plus another term. On the other hand, when I take a look at factorization, factorization is going to give me a result that looks like this, that is a term composed of quantities that are multiplied together. So notice that this is going to be a quantity multiplied to another quantity, and everything is multiplied together. Now, one thing that we also want to go ahead and take a look at, and I think you've probably realized this just by looking at this, is that distribution and factorization actually undo each other. In mathematics, this is called an inverse operation of each other. So distribution and factorization are inverse operations of each other. Now, we've already done a lot of things in mathematics that also are inverse operations of each other, like, say, for example, addition and subtraction, multiplication and division. You also have things like square root and squaring. This is just one more example of an inverse operation in mathematics. Now, before we get into any of the examples of how we can factorize, let's make sure that we know exactly what we're trying to aim for, because we don't just want to factorize, we want to completely factorize. Now, what does that mean? That means that your greatest common factor is factored out. Now also, just in terms of the way that we write things in mathematics, the first term in the grouping symbol after you factorize is usually positive. So if I have an expression that looks like this, generally speaking, we want this term in the grouping symbol to actually be a positive term. Lastly, how do you verify that the factorization is correct? Well, just distribute and see if you come up with the original expression that you started with. So let's take a look at a couple of examples here. Say, for example, I have 6x minus 12. If I wanted to go ahead and factor, I have to think, what is the greatest common factor? Well, I have two terms, 6x and minus 12. The greatest common factor would be 6. So then I can rewrite it as 6 times by x minus 6 times by 2. So I can factor out the 6, which is the greatest common factor, and I'm left with the quantity x minus 2. So notice that what I can do now to go ahead and determine whether or not this factorization is correct, I can just go ahead and distribute and come up with 6x minus 12. I know that I'm okay. Let's go ahead and take a look at another one here. This one is a little bit more complex just because of the complexity of each one of the terms, but the process is still exactly the same. What is the greatest common factor of negative 6xy and positive 12xy squared? On first thought, you might think, well, I can go ahead and take out a minus 6. I can factor out a minus 6x because that would probably be the greatest common factor. And if I take a look here, of course, I can factor out a negative 6x, and I'm left with a 2y squared. And so I can go ahead and say that the factorized form of this particular expression would be negative 6x times the quantity y minus 2y squared. But wait, notice what happens is that when we take a look at this here, when I take a look at what I have in the grouping symbol, I can actually factor something else out. I can factor out a y. So what I should notice here is that the greatest common factor has not been factorized out, and therefore I should actually go ahead and revisit my factorization to make sure that it accounts for the greatest common factor. So what is the greatest common factor then? Well, the greatest common factor in this particular case is going to be minus 6xy. Times that by 1, minus 6xy, times it by 2y, and so therefore I come up with a minus 6xy, times it by the quantity 1 minus 2y. And this will be its most factored form, completely factored form. Now, of course, if I wanted to go ahead and double check to make sure that this factorization is correct, I can just go ahead and distribute, and sure enough I come up with exactly the same expression that I started with, so I know I'm okay. Now, take a look at C. C looks a little bit more complex, like wow, look at all of that. We actually have two terms, right? Here's the first term, minus the second term here. How am I going to factorize that, and how did I come up with this? Well, it's the exact same property, exact same principles that we've been using, say for example, even in this case here. Now notice, this is already telling me what the greatest common factor is. The greatest common factor in that case is the x minus 3, because those are common factors for both terms. So if I factor out the x minus 3, I'm left with 5 minus n in the quantity 5 minus n, and I am done, because the result is a term composed of quantities that are multiplied together. Okay, so let's go ahead and wrap things up. Distribution, factorization, remember they are inverse operations of each other. The most important thing to remember about factorization is that you're going to be introducing a grouping symbol, and the result is a term composed of quantities that are multiplied together. Okay, how do you determine whether or not an expression is completely factorized? Make sure that the greatest common factor is factored out, and just by convention, make sure that b is a positive term. So there you go. We'll go ahead and take a look at more examples the next time that we see each other in class. See you then. Bye-bye.